Let us look at the next section, students. This section contains 8 questions. The answer to these questions are in the form of double-digit integers. Let us look at question number 25 now. NaCl form an ionic crystal in which Cl- form the CCP lattice. The number of Na plus present at a distance of under root 5 a by 2 from Cl- at the corner is. So if we talk about this distance from the corner, we can have the top face. Okay. So if we have a Cl- present here, so this distance is A and this distance is A by 2. Okay. So if we talk about the distance from the Cl- present at the corner to this H center of the adjacent side. So this distance will be given by under root of 5 into A by 2. Okay. So now if we talk about the number of these H centers, we can have the top view of the 8 cubes, of which the Cl- at the corner is a part of. So we can have the Cl- present over here, and we have to talk about all the points which are present on the adjacent H centers. So we have a total of 8 such H centers present in one plane. So there will be 3 planes in total. So if we talk about the total number of such points, there will be a total of 24 number of such points which are present at a distance of under root of 5 a by 2 from the Cl- at the corner. So students, for this question, the answer has to be marked as 24. Let us look at the next question now. Question number 26. Hexagonal closed packing has tetrahedral as well as octahedral voids. The total number of octahedral voids and tetrahedral voids per unit cell are 6 and 12 respectively. The number of tetrahedral voids completely inside the unit cell, that is, do not have a contribution in another unit cell, is x, then the value of 2x is. So students, if we talk about the HCP, so we can have an ABAB type of structure. So we can first draw the A layer. So this is the A layer, students. Now if we talk about the layer B, the layer B can be drawn like this. Okay. So if we talk about the tetrahedral voids which are present between layer A and B, we can see that there are a total of 4 tetrahedral voids which are present between the layers A and B. So we're going to mark them in red. So this is one of the tetrahedral voids. This is another tetrahedral void. So is this. So there are 3 such tetrahedral voids here, and another one is present at the point which is denoted. So if you talk about the tetrahedral voids which are present between 2 adjacent layers, there are a total of 4 TV which are present between A and B. Similarly, if you talk about the number of tetrahedral voids present between the layer B and the layer A which will be placed above it, similarly there are going to be 4 tetrahedral voids between B and A. So students, we can clearly see that there are a total of 8 tetrahedral voids which are completely inside the unit cell, which are not shared between adjacent unit cells. So students, the value of x is equal to 8, and we have to report the value of 2x for this question, and we have to report the answer as 16. Let us look at the next question now. Question number 27. Kolbe discovered the method of preparation of hydrocarbon in which the sodium salt of carboxylic acid is electrolyzed. If aqueous solution of sodium acetate is electrolyzed by current of 19.3 amperes passed for t second, and the total volume of gas collected at anode and cathode is 268.8 ml at STP, then we have to find the value of T. So if we talk about this electrolysis, students, so at the anode, oxidation is going to take place, and the acetate ion CH3CO- will convert into ethane along with the liberation of CO2. And if we talk about the total balancing, so 2 such acetate ions will combine to give us ethane and 2CO2, and there will be a loss of 2 electrons at the anode. If we talk about the cathode now, at the cathode, the reduction of sodium ions will not take place. Instead, it will be water which is going to get reduced. So H2O will consume electrons and convert into H2 and OH minus. So if we talk about the balancing, we can have 2H2O plus 2 electrons giving us H2 and 2 OH minus. Okay. So if we now talk about the total number of electrons and the total number of gases. So students, out of these species which are formed, ethane is a gas, CO2 is a gas, as well as H2 is also a gas. So we can clearly see that for a transfer of 2 mole of electrons, the total number of moles of gases produced is equal to 4. So 2 mole electron will form 4 mole of gases. Okay. Which means that a total of 2 farad charge will produce 4 mole gases. Now if we talk about the actual moles of gases which are produced, we have 268.8 ml. So if we talk about the moles of gases, it will be equal to 268.8 divided by 22400. So this will be equal to 12 into 10 raised to power minus 3 moles, or a total of 12 millimoles. This must mean that the moles of electrons is equal to half this number. So number of moles of electron is equal to 6 millimole, or a total of 6 millifarad has been passed. So 6 millifarad is equal to 19.3 into T upon 96500. So if we solve for the value of T from this expression, we have the value of T equal to 30. So students, for this question, the answer has to be marked as 30. Let us look at the next question now. Question number 28. If a solid PQ having NaCl structure is heated so that the ions along one body diagonal are lost and trivalent ions enter the interstitial sites to maintain the electrical neutrality, so that the new empirical formula of the unit cell is PXQYRZ, where X, Y and Z are the smallest possible integers. Then the value of X plus Y plus Z is. We have to assume that Q minus forms the lattice. So if we talk about the operation due to which the ions from the original cell are lost. So if we talk about the P ions or the P plus ions, so along one body diagonal, P plus is present at the body center. So initially there were 4 of them present. Out of these 4, 1 has been lost. So 4 minus 1. So this will be equal to 3. So total of 3 P plus ions are present in the new crystal now. If you talk about the Q minus, 4 such Q minus were present initially. Now due to the operation of removal of ions from the body diagonal, the Q minus ions which are present at the 2 ends, that is the 2 opposite corners, will be lost. So 4 minus 2 upon 8. The contribution of each ion from the corner is 1 upon 8. So there are 2 such ions. So if we talk about the effective number of Q minus ions which are present now in the system, so this shall be equal to 4 minus 1 by 4, which is 15 upon 4. So now if we talk about the total number of R3 positive ions which must enter to maintain the electrical neutrality, we have 3 minus 15 upon 4 plus n into 3 shall be equal to 0. So if we solve for the value of n from this expression, we have the value of n into 3 is equal to 3 by 4. So this must mean that the value of n is equal to 1 by 4. So if we talk about the crystal now, we have P3, Q into 15 by 4 and R into 1 by 4. So if we talk about the smallest possible integers, these numbers have to be multiplied by 4. So we're going to have P12, Q15 and R1. So we can see that the value of X is equal to 12, the value of Y is equal to 15, and the value of Z is equal to 1. So if you talk about the sum of X plus Y plus Z, we can clearly see that the sum comes out to be equal to 28, which has to be marked as the correct answer to this question. Let us look at the next question now. Question number 29. An alloy of 5 gram of Ag and Pt was added to excess of HNO3 and the volume was made up to 1 liter. A silver rod was dipped in the solution. So the E cell of the cell has been given to us. It is equal to 0.5 volt at 298 Kelvin. The value of E naught Ag plus to Ag is 0.8 and the Ag plus ion concentration is 1 into 10 raised to power minus x. We have to comment on the value of 5x. Students, if we talk about this cell, the E naught of this cell will be equal to E naught of the cathode minus E naught of the anode when we're talking about the reduction potentials. So the cathode has a reduction potential equal to 0.8, whereas the anode is the standard hydrogen electrode. So this is going to be equal to 0. So the E naught cell is equal to 0.8 volt. The E cell has been given to us. E cell is equal to 0.5 volt. Okay. Now we can apply the Nernst equation. So for the Nernst equation, the hydrogen electrode can be neglected as all the species present are given in their standard states. So we can have Ag plus electron converting into Ag. So the Q will be directly given by 1 upon Ag plus ion concentration, which is given to be equal to 10 to the power minus x. So this will come out to be equal to 10 to the power plus x. So now if we try and apply the Nernst equation, we have E cell is equal to E naught cell minus 0.06 by 1 into log of Q. So if we put the values, E naught is 0.8, E is 0.5 minus 0.06 into log of 10 to the power x. So this on simplification, minus 0.3 is equal to minus 0.06 into x, which means that the value of x is equal to 5. So students, if we talk about the value of 5x, the value of 5x will come out to be equal to 25, which has to be marked as the correct answer to this question. So the answer to question number 29 is 25. Let us look at the next question now. Question number 30. A solution comprising 0.1 mole of naphthalene and 0.6 mole of benzene is cooled until some solid benzene freezes out. The solution is then decanted off from the solid and warmed to 353 Kelvin, where its vapor pressure is found to be 608 torr. The freezing and the normal boiling points of benzene are 278.5 Kelvin and 353 Kelvin respectively. The amount of benzene that freezes out due to cooling is x grams. We have to comment on the value of 5x. So students, if we look at the data which is given to us in this question, now it is mentioned to us that 353 Kelvin is also the boiling point of the benzene. So it must mean that at 353 Kelvin, the vapor pressure of benzene is equal to 760 torr. So we have the relative lowering in vapor pressure data now. So it is given to us that the actual pressure is 608 torr. So we have P naught minus PS upon P naught. This should be equal to the mole fraction of the solute. So the moles of naphthalene is 0.1 and the moles of benzene, we can assume it to be equal to N. So this has to be found out. So P naught was 760, PS is 608 and P naught is again 760. So this is equal to 0.1 upon 0.1 plus N. So if we simplify the LHS, this value comes out to be equal to 152 and 760 and 152, they cancel out each other. So 152 into 5 times gives us a value equal to 760. So we can clearly see that 0.1 upon 0.1 plus N is equal to 1 upon 5. So we can clearly see that the value of N should be equal to 0.4. So the number of moles of benzene present now is 0.4. Initially it was 0.6. It must mean that the mole of benzene separated is equal to the difference between these numbers. So this is 0.6 minus 0.4. So that is equal to 0.2. So NB which is separated is equal to 0.2. So the grams of benzene which have separated is equal to 0.2 into 78, which is equal to x. We have to comment on the value of 5x. So 5x will be equal to 5 into 0.2 into 78. So this will be equal to 1. So the value of 5x comes out to be equal to 78. So students, for this question, we have to mark the answer as 78. Let us look at the next question now. Question number 31. A pure sample of camphor has melting point of 451.55 Kelvin. The melting point of solution containing 0.5 gram camphor and 0.039 gram of unknown compound was 432.7 Kelvin. If the unknown compound was a hydrocarbon containing 7.7% H, the molecular formula of the unknown compound is CXHY. We have to comment on the value of X plus Y. The value of Kf of camphor has been given to us. Okay. So if we talk about the depression in freezing point, so we have delta TF. So the freezing point of the pure sample of camphor was 451.55 and it froze at a temperature of 432.7. So if we talk about the delta TF value, it will come out to be equal to 18.85. Okay. So the delta TF should be equal to Kf into M. So we can put the value of Kf. So 18.85 is equal to 37.7 into the molality. So the molality value comes out to be equal to half. Okay. Now it is given to us that the solution was prepared by adding 0.039 gram of an unknown compound. So 0.039 grams divided by the molar mass of the hydrocarbon will give us the number of moles of solute. It was added in 0.5 gram of camphor. So this is 0.5 and it has to be multiplied by 1000 to give us the value of the molality. Okay. So now if we talk about the molar mass of the solute, so we have capital M is equal to 2 into 2 into 39, which is approximately equal to 156. Okay. So the molar mass of the solute is 156 gram per mole. And now if we use the percentage composition of the hydrocarbon, we have 7.7% H. So it must mean that the remaining must be carbon as it is a hydrocarbon. So 92.3% is carbon. Now if we talk about the number of moles, so H has to be divided by 1, so which will give us 7.7 itself. And if we divide 92.3 by the molar mass of carbon, that is 12, it will also come out to be equal to approximately 7.7 itself. So it means that the empirical formula of the hydrocarbon is CH, and using the molar mass data we can find out the value of N. We now have the molar mass of CHN is equal to 156 grams. So if we simplify for the value of N, we have 13 into N is equal to 156, which means that the value of N is equal to 12. So students, the formula for the hydrocarbon is C12H12. So X is equal to 12 and Y is also equal to 12. So if we talk about the sum of X and Y, we get a value of 24, which has to be reported as the answer to this question. So the correct answer to question number 31 is 24. Let us look at the next question now. Two volatile liquids A and B form ideal solution at 300 Kelvin. A graph between reciprocal of total vapor pressure of solution 1 by PS with YA is depicted below, where PS is the total vapor pressure of solution and YA is the mole fraction of A in the vapor phase. Okay. So the examiner seems to be interested in the vapor pressure of B in the pure form, which is PB0. Okay. So now if we look at the graph which is given to us, students, if we put the value of YA equal to 0, so the value of Y equal to 0, it must mean that there is no A present in the vapor phase, which by extension implies that there is no A present in the liquid phase itself. So the pressure exerted will be equal to the vapor pressure of pure B. So when YA is equal to 0, then XA is also equal to 0 and PS will be equal to PB0. Okay. So using the graph, if we put the value of Y is equal to 0, we have the value of 1 by PS equal to 2 into 10 to the power minus 2. So 1 by PS is equal to 2 into 10 to the power minus 2. So PS, which is equal to PB0, in this case, shall be equal to 100 by 2, which is equal to 50. Students, for this question, we have to mark the correct answer as 50. Let us look at the next section now.